Welcome to Functional Tutoring. We're going to go over some pre-calculus problems, just very simple ones. Question 1, a factory produces bottles worth 50 cents each. 50 people work in the factory and each of them make 200 bottles a day. What is the total value of the bottles produced daily? So this is a simple multiplication problem. So what we're going to do is we're going to figure out how many bottles the factory produces in total each day, and then we're going to multiply the value of each bottle by that amount to figure out what the total value of the bottles is for each day. So we know that 50 people work in the factory, and each of them produce 200 bottles daily. So this is equivalent to, this is people, right? And this right here is bottles. So this means that each day, the total number of bottles produced by all the workers in the factory is 10,000. Now, we want to find the total value of this amount, and so what we'll do is we will multiply 10,000 by the value of each bottle, and this will give us $5,000. So $5,000 is the total amount produced daily in bottle value. Alright, question 2. Factor the polynomial a squared minus 2ab plus b squared. So this is what we would call a perfect square. You can see from all the answers that they're all in perfect square form. And this simply means that you can write it in terms that are something like this instead of something like this, right? It's not two terms, it's one term squared. So this is what a perfect square represents. And so we're going to try and factor our polynomial in a way that creates a perfect square. So let's just rewrite our problem. A squared minus 2ab plus b squared. And now essentially we're looking for two terms that they're the same term, right? Because we have to be able to factor it in this kind of perfect square system. So we're looking for two terms that are the same, that multiply to positive b squared and add up to negative 2ab. Well, we know that, let's try this. Let's try a plus b squared. We know that this is not going to work. And the reason for that is that when we multiply through, we're going to get plus 2ab. And we can see that by expanding out. Since we have positive terms here, when we multiply, we're going to FOIL, right? So a squared plus ba, let's do ab, plus ab plus b squared. So this would give us a squared plus 2ab plus b squared, which is not what we're looking for. We're looking for a negative here, right? So we can get rid of all this. This is how you would work through these kinds of problems. You would think through, what do I need to multiply and what do I need to add, right? So we have a positive here and a negative here. This means that we're going to be multiplying two negative numbers. So since we're going to be multiplying two negative numbers, let's try a minus b squared. Well, we'll distribute it out. So a minus b times a minus b, and we'll FOIL, and this would give us a squared minus ab minus ab plus b squared, which would give us a squared minus 2ab plus b squared, which is the value we are searching for. So this is how you go about solving these kinds of problems. You look for ways to multiply to give you the third term and add to give you the second term, and then you just test. You just test these values out. So on to our final question. James is doing some spring cleaning and has a large box with a base area of 3 square meters and a height of 25 centimeters. He's trying to figure out how much of his stuff he can fit into this box. Help him out by figuring out the volume of the box. So we want to find the volume of the box. We have to remember that for a cube, or in this case a box, volume is going to equal the width, you could say, times the length times the height, right? It's essentially 3 dimensions, so 3 different sides. So for this problem, we have the volume is going to be equal to, well, the width and the length we have, they are 3 square meters. That's the base area. So these two components here, these are the base area, right, of 3. So we can just simply replace those with 3. And now we're multiplying it by the height. The height is 25 centimeters. So 25, I should probably write this with units. So 3 meters times 25 centimeters. Now, the only problem here is we have to maintain the right units. So if we multiply this out, we're going to get something like 75, but it's going to be in terms of, we're going to have it in this weird sort of unit, meter, centimeter type thing. And that just doesn't make any sense. So we have to convert either 3 meters to centimeters or 25 centimeters to meters. Since all of our answers are in terms of meters, we should convert it to meters, but it doesn't really matter which way you go. So we have to just remember how to convert 25 centimeters to a meter. So what is a centimeter? 100 centimeters is equal to 1 meter. And so 25 centimeters is going to be equal to 1/4 of a meter, right? Or 0.25 meters. So we can rewrite this equivalently as 3 meters times 0.25 meters. Now, just multiplying this through, what we're going to get is 0.75 meters, which is the total volume of the box James has.